Exception handling in Python. Error correction is the tedious process in programming environment, particularly for learners who don't have any proper knowledge on the syntax and semantics of any programming language. So right from C, C++, Java and Python, if you consider any programming language, the most important thing is error correction. So various languages follows various notations for executing programs. If you observe C and C++, and if you are running on Turbo C environment or Turbo C++ environment, we use the terms compilation and execution. We use the commands Alt F9 for compilation, Control F9 for execution. So compilation is the process of checking for syntax errors like comma, missing semicolon, missing double quotations, missing parentheses, and etc. In Java, we use Java C filename.java for compilation and Java class name for execution. So we don't use the term compilation and execution in Python. As Python is an interpreted language, we use the term execution. So you run the program. So the logic of any program should be straightforward to make it hard for bugs to hide. So what happens if you get an error? There are two things in programming environment. If you get an error, so you correct the error and rerun the program. Sometimes what happens is the error makes you to come out of the program, abnormal termination of the program. So we have syntax errors, runtime errors, or logical errors in any code. Every programming language will be having a set of rules to be followed while writing the programs. If you are not following the rules, every statement in C language must end with semicolon. Every declaration statement must end with semicolon. All the statements must be placed within braces in C, C++, and Java. Variables must be separated by comma in variable declaration. So these type of rules to be followed in programming environment, and you get syntax errors if you won't follow. So once there is an error, syntax error, the program doesn't execute unless and until you rectify the errors. So in Python, look at the simple example. So marks is equal to 10 if marks greater than 20, print good score. So you have syntax error, missing parenthesis on print. So did you mean print good score? So you had to put that within parenthesis. The advantage in Python is if you have a syntax error which is reported by the Python interpreter, it gives you a brief explanation about the error and it gives you a suggestion to rectify it. If you have a syntax error while running the program in script mode, A dialog box will be specifying the name of the error and a small description about the error. So look at the if condition here and look at the error. So what is exception? Even if a statement is syntactically correct, so there might arise an error during the execution. So what type of errors you get during execution? Division by zero, index out of range exception in arrays, and many type of errors. So these type of errors will disrupt the normal execution of the program, and we call them exceptions. The term exception handling comes into picture only if the language is object-oriented programming language. The programmer must focus on type of errors what we get in writing the program. So all the object-oriented programming environments, they are having built-in exceptions. So we have syntax error. This will be raised if there is an error in the syntax of the code. And value error, IO error, so we have keyboard interrupt, zero, division error, index error, name error, and so on. So we'll be discussing one after one. The common error is arithmetic exception, that is division by zero. We are trying to open the file which is not existing. We are trying to create the object where the class is not there. We are trying to access the members of the class through object, but their members are not available. So you get errors in these type of situations. So look at this example, print 50 by 0. 50 by 0, 0 division error, that is division by 0. So if I type print var plus 40, var is a variable, but without defining the value of the var, you cannot add 40. So you get name error. If I type 10 plus 5, 5 is placed within quotations, you get type error because one is integer, one is string. Unsupported operand type for plus. I can use plus for two numerical values, even for two strings, but I can't use it for one numerical value and one string. 10 plus 5 within string quotations, you get type error. So when an error is detected in the program, the Python interpreter raises an exception. We use the term throws. So we'll be having exception handlers to execute when a specific exception is raised. Once an exception is raised, no further statement in the current block of the code is executed. So an exception involves interrupting the normal flow execution of the program and jumping to the part of the program and where there is a handling sessions. So we use raise statement to throw an exception. Look at this example, raise exception. The argument is generally a string which is to be displayed when an exception is raised. So the error can be a built-in exception or maybe user defined exception. So look at this example here. So we have numbers 40, 50, 60, 70 and the length is 10. If length is greater than length of numbers, raise index error. So you get index error here. Asset statement, and this is used to test an expression in a program code. If the result after testing comes false, then you raise an exception. And we use this in the beginning of the function and after a function call to check the valid input. So on encountering an asset statement, Python evaluates the expression given immediately after the asset keyword. If this expression is false, an assertion error exception is raised, which can be handled like any other exception. So look at the code. So we have a function negative check asset number greater than or equal to 0. Look at that. Comma, oops, negative number. So you are printing number multiplied by number and two function calls. So look at the first function call. I passed 100, so 100 multiplied by 100, I got something. And in case of minus 350, so you have an assertion error. Oops, negative number. So in this code, the statement checks for the value of the variable number. So if the number is a negative value, assertion error will be thrown and the remaining statements will not be executed. So how do you handle exceptions? So we need to write some additional code to give proper messages to the user whenever there is an exception. So this is exception handling. So exception handling is used in most of the programming languages like C++, Java, Python and many. So we use the term try, catch, throw, throws and some other terms, and we use finally in Java. So exception handling can be done for both inbuilt as well as user defined. When an error occurs, the interpreter creates an object called exception object, and this object contains information about the error, the type, file name and the position where the error has occurred. So when an exception occurs while executing a particular program statement, the control jumps to an exception handler, abandoning the execution of the remaining program statements. So the runtime system always searches for the exception handler. So you write to handle the raised exceptions. An error encountered in a method, so you get an exception object. An exception is raised and it searches for the exception handler. If it is found, then execute the code. This is what you call catching. If it is not found, it searches for methods in call stack and reverse sequence. So throwing an exception. So you have to design a code to handle a particular exception to be executed. So whenever there is an exception, automatically you need to go to that location where the handling code is there. So that is called catching an exception. So we have a try block. Try block is the area where you put the logic of the program where you are expecting some errors. So look at the try block here. Numerator is 50, denominator you are reading the input, and quotient is equal to numerator by denominator. So we have exception 0 division error. If at all the denominator is 0, automatically the control will be transferred to the statement which is mentioned in the concerned exception handling. So you get denominator is 0 not allowed. So we have a statement print outside the try and except block. So if the denominator is a non-zero value, you get a message division performed successfully. So when the user enters 0, the execution of try block will be stopped. The control will be shifted to except block. So whatever the message, whatever the code you write will be executed. So we have two test cases here. One, the denominator is 12 here, and the other one is 0. Check out what happens if you enter 12 and what happens if you enter 0. So if you enter 12, so you get division performed successfully, and the statement which is outside the try block and exception block will be displayed, will be executed. So if I enter 0, so control enters the exception block. So the statement which is specified will be executed. You get a message denominator as 0 not allowed. And then come to the statement which is outside the try block as well as exception block. So we can have any number of exception blocks. So based on what type of error we are expecting. So one try block, we can have any number of exception blocks. So I have two blocks here. One is 0 division error, other one is value error. In value error, I have a message only integer should be allowed. So I have two types of exceptions using two except blocks for a single try block. Whenever there is an exception raised, automatically it will be searching for the matching exception block. If it is found, then the concerned statement specified in that block will be executed. If it is not found, then the program terminates. So what happens if an exception is raised for which there is no handler created by the programmer? So look at this example. So we have accept value error and we have accept. The accept class without specifying any exception. So in this code, the denominator entered is 0, then the handler for 0 division error exception will be searched. As it is not available, the last accept class without any specified exception will be executed. So you get the message, oops, some exception raised. If we don't have any matching except block, so this happens. So we can use an optional else clause along with the try and except clause. So look at this example. So we have one try block and we have two exception blocks. One is zero division error, other one is value error. So look at the logic in try block. We have numerator 50, denominator to be entered by the user, right? Quotient is equal to numerator by denominator. So if you enter the denominator as 5, so you get the message division performed successfully, and it goes to the else. The result of division operation is, you get the value, as there is no error in the try block. So we have optional finally clause, just like in Java. The statements inside the finally block are always executed whether there is an exception occurred or not occurred. So what other things happens? It finally goes to the statements which are specified in finally clause. So always you have to put the finally at the end of the try clause and after all the except blocks and even the else block. So whatever things happens in try block, whether the match or an exception found or not found, the control goes to finally clause at the end, and whatever the statement specified will be executed. So we have a brief notes on this. If there is a syntax error, Python displays the name of the error and small description.